Hi, I'm Ihsan Dalgic, Application Engineer for HIOKI USA. In this video, I'll talk about how to accurately measure the electrical parameters of a capacitor. Most engineers are very familiar with a digital multimeter, just like this one. And for measuring capacitance, you simply bring it to the capacitance setting and you touch the leads of the capacitor with the probes and it takes a measurement. Very straightforward. Now, a multimeter is fine for casual measurements, but sometimes the value of your capacitor could be outside of its range. Or sometimes you want to measure the parasitics of a capacitor and make sure that it's fit for the purpose to which you need it for. Or simply you want to take a more precise measurement of a capacitor. For that, you will need a different instrument, which is an LCR meter. Now with an LCR meter, the L, C, and R represent inductance, capacitance, and resistance. And the way these instruments work is they generate an AC test signal of a certain voltage amplitude, and they measure back the resulting current, and also they measure the phase angle between the current and the voltage. And from these measurements, from these parameters, they can derive impedance, and from impedance they can derive capacitance, inductance, resistance, etc. Now, you may have also heard of the term impedance analyzer. Now, the difference between an LCR meter and an impedance analyzer is typically the impedance analyzer will have a more sophisticated front end. So it will have, for instance, frequency sweeping, graphing functions, or various calculation functions for equivalent circuit analysis. But electrically speaking, they both measure in the exact same way. A lot of engineers might be puzzled the first time they use this type of instrument. Sometimes the measured value is not what they were expecting. And when they measure a different type of capacitor, the value is what they were expecting. So is it the instrument at fault, or is it the capacitor? So what's going on? Now, HIOKI's LCR meters aren't particularly complicated to use. However, they will offer more settings, which allows you to change the test parameters such as test frequency, the amplitude of your test signal, in addition to DC bias settings, for instance. And since capacitors have parasitics, they're not ideal components, your test conditions will impact your measurements. So in this video, I'll be measuring this 220 microfarad electrolytic capacitor. And this one happens to be a bipolar type, and it's intended for use in audio applications. However, I did look at the datasheet ahead of time, and it is specified at 220 microfarads plus or minus 20%, tested at 120 hertz. So here we have the IM3536 LCR meter, and it has the 9262 test fixture, which is designed for testing through-hole components. So I'm going to put my capacitor into the test fixture. I just unscrew it like this and then tighten it up. Okay. So what I'm going to do is I've set the AC level to 0.5 volt. The DC bias I've left off because I know this is a bipolar capacitor, so DC bias voltage is not necessary. Frequency, I've decided to start at 20 hertz. I know this is an audio capacitor. It's used for audio applications, in audio circuits. So 20 hertz is the lowest frequency within the audible range, so I decided to start with that. So let me go ahead and take the measurement. And as we can see, measurement is 222.712 microfarads, and that measurement is well within datasheet parameters, plus or minus 20%. So next, let's test it at 120 hertz, and this is the datasheet frequency. And as you can see, at 120 hertz, it's also within range. It's passed at 217.63. In this video, I hope I've been able to demonstrate just how easy it is to measure a capacitor like this one using one of our LCR meters. In order to make the most accurate measurements, you need to test the capacitors at the frequency and test conditions that are specified by the manufacturer. If you want to make sure that the capacitor is within datasheet parameters for your particular application, you can also test it at the frequency that it's likely to work at within your application. If you've enjoyed this video, please don't forget to like and subscribe to our YouTube channel. And you may also leave your comments. And don't forget to visit our website at the link below. Thank you.